Hello everyone, welcome to this video. It's A Plus Natural Sciences tutorials. Now we have a question falling under the ground state electronic configuration, and it says write the GSEC, which is the ground state electronic configuration for number 1 sodium, then we have sodium ion, nitrogen, then we have the nitrogen ion. So how do we write the GSEC for these elements and ions? So one thing that you need to remember about the GSEC is is the order in which the shells are arranged. Okay, in short, the subshells. We call them the S, P, D, F, G, and so on electronic configuration. The SPDF, these letters that you are seeing are just the subshells that are found in the energy levels. Now, each of these has a maximum number of electrons it can hold. Making sense? Each of these has got the maximum number of electrons. This one can hold up to 2 electrons. This one here can hold up to 6 electrons. The D can hold up to 10 electrons. The F can hold up to 14 electrons. The G can hold up to 18 electrons, and so on. So there's a difference of 4, 4, 4. So now, from here, we can clearly see that the sodium has got the proton number, which is what? 11. Okay? So 11, with the first shell, okay? So here is what I'm going to. So this is what can help you remember. Okay? So when you move down like that, that means that is your first shell. You move again down like that, you have 2s, then you have that, you have 2p, then you have 3s. Moving just like that, we have 3p, we have 4s, and so on. That's how we move. So this is the line in which we are going to move. So let's go for this for sodium. 1s is going to have how many electrons? 2, like I said, right? Then from 1s we have 2s. 2s can also, as long as it's the S sublevel or subshell, it is still going to have 2. Then from here we have a 2p. We have a 2p. By the way, we need to be counting. We have 4 here. From 11, we have how much? 7 and many. So we are going to put. Remember that the p orbital can hold up to 6. Then from the p we have the 3s. In as much as we know that the 3s can hold up to 2, there's only 1 electron remaining. And from here, you can clearly see that the 3s shell is telling us that sodium is found in group 1, because on the S sublevel we only have what? 1 electron, indicating that the third level for sodium is going to be 1 electron there. That is for sodium. What of for sodium ion? For sodium ion, remember that for a positive ion, it means that an electron was lost. But an electron can only be lost from the outermost shell. You get the concept, right? So from this shell, that's where we are losing an electron. That means for sodium ion, we are having 1s2, 2s2, 2p6. This electron has been lost. Is it true? Yes, because once an element becomes charged and it loses a certain number of electrons or obtains or gains, it's going to remain with the 8 electrons according to the octet rule, or 2 to the duplet. So it's going to remain with 8 electrons in the outer shell, which is true because the second shell here, which is 2, 2, which is common, is telling us there are 8 electrons in the outer shell. The S shell has got 2 and the P has got 6. When you add, you are going to get 8 because they are all in the second shell. Let's go for nitrogen. Nitrogen has got 14 total number of electrons, right? Exactly. So we have 7, not 7 total number of electrons. So we'll have 1s2, 2s2, and 2p3. This has quantity, right? You don't have to force a 6 here. Whatever electrons, number of electrons that has remained, please put it there. Yes, but what of for the the nitrogen ion? A negative shows that this guy has gained 3 electrons. So it has gained 3 electrons. That means what we are going to have now is 1s2, 2s2, 2p. Those electrons are going to come here. So that will be 6, which is true because we have a second shell has got 8 electrons in the outer shell. That's all. I hope this made sense.